Good day, everyone. I am Kirby Armanalo, and today I'll present a case study on how electrical resistivity tomography, or ERT, was used to explore groundwater in drought-affected areas in Buriram Province, Thailand. It is a work of Saoanunt in Yungsukkasam 2024. This method helps to identify underground water sources, which is essential for improving water access and resilience during dry season. For starters, Buriram Province suffers from chronic drought, especially during dry seasons. Although groundwater could help, uh, much of it is too salty for use. So this study uses ERT, a non-invasive imaging method to locate fresh water underground, offering a valuable tool to locate water management or for local management. As for the objectives, the main goal of this research is to map the groundwater zones using ERT to confirm those results with actual borehole data and to provide reliable information for future groundwater planning. Before we dig deeper to electrical resistivity tomography method, let us first understand its overview. So ERT works like a medical scan of the earth. It sends electrical current through the ground and measures how resistant different layers are. Fresh water has a low resistivity because it conducts electricity, while dry rocks resist it more. They use a Schlumberger configuration, which provides good depth coverage and reduced surface noise. It is important for the accuracy in an even terrain like Buriram province. Let us now move on to the survey equipment and sites. So the researchers used Geomative JD10 series system for data collection. Survey were conducted on these three drought-prone districts. The first one is the Khok Lek, where we can find here in the uh, Wairat district, then the Mueang Fang, Mueang Fang Subdistrict located in the Mueang district. Then we can, the third location rather is the Banda Subdistrict, which we can find in the Bandan district. So figure 1 shows their locations. Each site has a survey depth of 55 up to or 50 to 55 meters deep, enough to reach potential aquifers. Let us now move on to the data processing. After collecting field data, they used RES2DINV software to create 2D resistivity models. These images called pseudo sections, like this one, shows cross section of underground layers. Inversion model refines a raw measurement, helping distinguishing between water-bearing zones from dry layers of rocks. Now that we are done with these concepts and overview, we can now go to the location one, which is the Khok Lek Subdistrict. It has a transect of 300 meters and 5 meters spacing. Its depth is 50 meters from here up to here. Then its key layers are topsoil, sedimentary rock or sedimentary layer, and then the aquifer. So this profile suggests a promising water potential at deeper levels. Now, let us move on to the Mueang Fang, the sub-district. It has a 374 meter transect and 5-meter spacing. It has a depth of 55 meters, and freshwater aquifers can be found in 3 to 20 meters. So this site shows a shallow aquifer easily accessible for pumping. Now moving on to the last ERT scan, let's have the Dan Subdistrict. So Dan Subdistrict has 264 meters transect and 5 meters spacing. Its depth is 55 meters, and the aquifer zone is 5 to 50 meters. So this location has a multiple aquifers useful for sustainable groundwater extraction. Now that we have all these graphs, it is now time for the validation. First one is the borehole validation. To verify ERT results, a borehole was drilled at Mueang Fang, which is seen here in the figure number 5. These, and these 5 boreholes where water was detected from 9 to 50 meters underground, which closely matches the ERT profile. The borehole encountered sediment, sand, clay, and sandstone, all good water-bearing materials. So this confirms that the resistivity model reliably mapped the aquifer. As for the water level monitoring, to evaluate long-term sustainability, 5 wells were monitored from 2020 to 2022. Figure 7 shows the groundwater levels remained stable. This one. They are monitored throughout the whole 2 years. This consistency proves that the aquifer system can be relied on during dry spells. Moving on to discussions, overall ERT method successfully identified groundwater zones in all 3 sites. The data matched well with the existing geological report and borehole findings, providing its accuracy. This study demonstrates that ERT is a powerful tool, especially in regions with limited water. To conclude, groundwater was found at depths from 9 to 50 meters. The aquifer shows good yield stability. ERT is a cost-effective, non-invasive method for guiding water resource development in drought-prone areas. That is all, and thank you very much for your attention.